What are these rare earth minerals and why are they so important? Why are they so rare? What is the current dynamic of the rare earth minerals? And finally, if there is any other solution to the rare earth minerals. Please subscribe to this channel to stay tuned to us. These minerals are found in Earth's crust. They are heavily utilized in today's technological advancements due to their unique magnetic, optical, and electronic properties. But as the name suggests, rare earth minerals are not that rare in the Earth's crust. However, we will discuss why they are called rare later. Let's see the wide range of use cases of rare earths in modern technology at a glance, so we know why they are so important. Rare earth elements like yttrium and europium are crucial for computer color and display. Neodymium and terbium are used to create powerful magnets that are used in hard drives and other components of a computer. Germanium and gallium are used in semiconductor manufacturing processes to enhance properties like electrical conductivity. In a computer alone, a lot of rare earth elements are necessary. The smartphones, batteries, automobile industry, especially electric cars, oil refineries, the aerospace industry, and other electronics like loudspeakers, cameras, and wind turbines use all different kinds of rare earth elements. Modern military equipment such as F-35 jets, Tomahawk missiles, and Predator unmanned aerial vehicles is also heavily dependent on rare earth minerals. So, having a heavy mineral reserve in any country can be the most important asset in this era of technological advancement. Where are all the minerals coming from? Unsurprisingly, China has the biggest reserve, 44 million metric tons. The next highest reserve is in Vietnam, 22 million metric tons, half of what China has. And Brazil, Russia, India, Australia, and the United States follow. Here's the interesting part. Having the reserve alone is not enough. Not all countries have the resources to mine those minerals. First of all, mining itself is an expensive and time-consuming process. Exploration of rare earth minerals, permit process, mining, processing, and refining everything may take from 5 years to 10 years or even more time to finish. For the whole process, it may take $15,000 to $45,000 for each ton of minerals on average. On top of that, there are 17 rare earth minerals, and many of them have very similar chemical properties. Separating them from each other during processing is technically complex and expensive, which is not affordable for many countries. Also, mining can be possible only if a large enough quantity is present in a certain place. Extracting and refining rare earths often involves toxic chemicals and produces radioactive waste like thorium. Because of these risks, strict regulations make the extraction process even more difficult in many countries. After all these troubles, the biggest producer of rare earth minerals again is China. The largest rare earth element mine in the world is the Bayan Obo mine, located in Mongolia, and this part of Mongolia is in China. The United States is the largest importer of rare earth minerals from China. In the years 2020 and 2023, 70% of America's rare earth imports came from China. Malaysia, Japan, and Estonia are the other major suppliers. Here is another twist to the story. Look at this graph. China is not only the biggest exporter, but it is the biggest importer as well because of their large manufacturing and processing industry. China produces 60% of the rare earth elements and uses nearly 90%. As they are the biggest exporter, you can imagine how much China has to import. Maybe you are thinking why China exports a large amount of its minerals and then imports from other countries. Here is the answer. China is the biggest exporter of heavy rare earth elements like dysprosium and terbium, and its biggest imports are gadolinium, yttrium, terbium, and dysprosium. And they have a large defense system that also requires a significant amount of rare earth minerals. China's imports depend primarily on Myanmar and Thailand. A lot of time, China only imports the raw composite chunks and then processes and extracts the minerals from them. As you know, not every country has the processing technology. As I mentioned in the beginning, rare earth minerals are rare not because they are actually rare, but because the processing power is limited to a few countries, with China being on top. Access to the rare earth minerals and pricing both depend on the trade policies, geopolitics, and business strategies of these few countries. Right next to China, Japan comes second in the import category, with much fewer imports than China, followed by Vietnam and the United States. If you look at the exports and imports lists, it's a pretty complex chain, but China alone controls 85% of the rare earth mineral market. Now, do we have to be dependent on these rare earth minerals, or is there any other solution? Research has been going on for decades to eliminate the need for rare earths, and some alternatives are there now, but they are limited and application-specific. At the same time, the alternatives are often more expensive and less efficient. For example, in the production of EV motors, wind turbines, and hard drives, ferrite magnets can be used instead of rare earth neodymium or dysprosium, but ferrite magnets are much weaker. There are alnico magnets, which are a mixture of aluminum, nickel, and cobalt, but they're much less powerful. In the same way, there are some alternatives to phosphors and catalysts as well to use in the LEDs, screens, and oil refineries, but not good enough to eliminate the need for rare earth minerals. At least, for now, we do not have any alternative to mining Earth's crust for rare earths. But humans have always done wonders in the past. I am sure there will be much stronger alternatives one day.